Greetings and welcome, my friends, mathematicians and math fans, number fans of all ages. If you're looking for a video about data and statistics, you done found it. It's great to have you here. Today we're talking about describing the shapes of data distributions. It says the following. It says, recall that a histogram is a bar graph, except these done histograms show the frequency of the data values in intervals of the same size. Question, comment, observation. No, it's already on your packet. You should follow along. You could highlight things. You should write notes when we get to the example. Yeah. Well, it can't hear your guys' questions or comments, actually, oddly enough. The mic doesn't pick up on this side. Pretty cool. Oh, sometimes, yeah, if I was a better podcaster or video YouTuber, I would restate the questions so that the internet audience would hear. You're right. Good catch. So guys, a histogram is a type of bar graph that shows how frequently data values land in a class or a group or a bucket, okay? So a histogram is another useful data display that shows the shape of a distribution. So notice the following. Here are some different ways that data can be distributed. Now, this actual outcome is very similar to when I looked at the last 5 years of our school data of our test averages here at Brattleboro Union High School. That our test averages made this type of shape, which can be called as skewed left because the data tails off. It's got a long tail on the left side. We would call that skewed left. And similarly, Jake, most of the data is on the right side of the graph, right? A lot of the numbers land here, and then it tapers off on that side. Symmetric data, okay? Symmetric data, a lot of things land in this category. Oftentimes, height of humans land in this category. Yeah, there are some really tall people, and there's some really short people, but typically most people land in this middle range, and it's less and less frequent that someone super tall is going to show up in the population. So this is symmetric. When you have a symmetric data set, the best measure of center, so the best measure of center is actually your mean. Whereas in these other ones, you should use median. Okay? And you might describe its distribution with either a box and whisker or, in this case, a histogram. All right, skewed right graph is when most of the data is on the left and the tail is to the right. Skewed right. You guys, you done got it? You done got it. All right. Describing the shape of a distribution. Here's example 1. This is where you guys come in. Hooray. Hooray. Here we go. All right. I don't think I gave you a little graph, but let's make a little bar graph. More specifically, a histogram. So I'm going to make kind of like an x-axis, y-axis sort of thing going on here. No, that's all right. So guys, watch this. So I'll have yeah, I guess I'll have 1, 9. I'm picking just the starting number for each of these for my label. 17, 25, 25, some might say. 33. Anyone notice the pattern yet? What am I counting by here? Like by 8, I think. Yeah, 41 and 49. And I do my best to make all of these widths identical. Now, what's the highest frequency that I've got that shows up here? Looks like 25. So I need to go up at least as high as 25. I'm going to count by 5s, tell you what. Let's see, 5, 10, 15, 20, and 25. And now I'm going to make a beautiful histogram, friends. So for my bar between 1 and 8, up to the edge of 9, I've got 5. So this bar is going to be this high, and it's going to be, right, that wide. Then I've got to go 9 high, so I'm going to go up to roughly where 9 height is. this next bar. Something like that should do. Beautiful, beautiful. And then I've got to go 16 high for this next one. So roughly 16. Right, these aren't going to be perfect, but that's okay. There's 16 high. If you wanted, you could even label these if you're a super friendly person. You don't have to. 25 high is the next one. And the width of these bars should all be the same, and the bar's edges should be touching. Then I've got 20. And 8. Guys, wait a minute. Did I miscount? What did I done mess up? 16, 25. Oh, I need one more bar. Yeah, that's okay. There's my problem. Classic Waddy. Oops. That's all right. So then I need an 8. And lastly, I need 7. Right? So, here's my setup, right? Here's my setup. So there's, I guess this technically would be at 57, whatever. So yeah. So isn't that lovely? You guys, you think that's all beautiful? It asked me then to describe. Here, Jake, you can be quiet for the rest of class. It asked me then to describe the shape of the histogram. Tell you what, guys, I think I actually want, you know what? I want to color this in. Mis amigos. See, can I do this? Boom, 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 boom. Look at that. Beautiful. No, you don't. But there you go. So there's my histogram. Could someone describe the shape for us? Yeah, Ben. Right? If I tried to draw it like this, it looks symmetric. It looks symmetric. Don't worry about it. I'll tell you when we're done. We're fine. We're fine. So there we go. Also, I guess it would be a good idea to label these. Right? This was measuring number of tickets sold. And this is just for all histograms, this is going to be the frequency. You might describe this as a number of, number. I sometimes use the word, what's the word I use? Quantity. Quantity. Yeah. Here we go. Let's try to get one more in here. Ready? All right. Let's see how far we can get. Choosing appropriate measures. Use the shape of a distribution to choose the most appropriate measure of variation when describing the data. All right, looks like this one here. So it says, when a data distribution is symmetric, use the mean to describe the center. All right, actually, I'll do mean in this color. So mean is what I would use here. And use standard deviation to describe how spread out it is. We'll actually, tomorrow, I think, be talking about standard deviations. Maybe the day after. If the distribution is skewed, you use the median. It will actually better represent the data than the mean would. Yeah, it's going to be on the homework. And use the 5-number summary. What is the 5-number summary? That's Q1, that's Q2, that's Q3, that's your low and your high, right? That's a box and whisker plot right there. So that's how you would represent it in that case. All right, well, thanks for watching, mis amigos de internet. Adios.